Okay, so I'm going to switch to the this camera, and you can see, right? I hit it. Okay. I have a second camera here.
Okay.
So that I can look down at the paper. Okay. So can you read it okay?
Yes.
Let's put some numbers down, right? Let's say we don't do a lot of math. Not a lot of math, only a little bit. But you need to be able to do something, okay? So let's put down, there's a number, 365. That's just a number, right?
Yes.
And this number is not in scientific notation. So we want to learn, what is scientific notation? It's a way of writing the numbers, especially really big numbers. Now, this one's not so big, but I want to teach you with a small number because it's easy, right? So when you look at this number, do you see a decimal point anywhere? Any decimal?
No.
So if you can't see it, you always put it at the end of the number. That's where it is.
Okay.
Okay? Now, the trick with scientific notation, it has two parts to the number. The first part is a number between 1 and 10, right? And then you go times, and it's going to be 10. You're going to put in some power here. You're going to have some power that we're going to put in. Okay? That's the format.
Okay.
So how do you do it? Okay, well, is this number between 1 and 10? Is between 1 and 10, or is it bigger than 10? This is 365. Is it bigger than 10?
Yeah.
Of course,
That number?
right? Of course it's bigger, right? So what I'm going to do is move the decimal point. I'm going to move it this way. Now what number do I have?
36.5.
Yes, of course. Is it bigger than 10?
Still bigger.
Still bigger. So I have to keep moving. I got to go one more time. Now, how many times did I move it? 2 times. Okay.
2 times.
This is important. So the number that I have is what's the number now?
3 is smaller than 10.
Yes, it's more than 1, but less than 10.
Yeah.
So it's 3.65. Okay, that's the first part of the number. Simple, right? You just moved it until it's between 1 and 10. Now, you have to count. How many times did you move it?
3.
2 places.
Oh, no, 2. That's
2, right?
Sorry.
So this becomes
1, 2.
times 10 to the second power. 10 to the second power.
Oh.
So is this familiar or is it not so familiar?
Kind of.
A little bit? Okay, let's review something else. Okay, so when I write down, what does this mean? What's 10 to the second power mean? What does it mean?
10 to potential 2.
Yeah.
We need to multiply 10 times 10.
10 times 10. Yeah. What's 10 times 10? You can do that in your head.
100.
Of course, 100, right?
100.
It's just a fast way to write it, right? It's a fast way to write it.
Oh.
Now, usually the numbers we're going to have are going to be much, much bigger. So I'm going to show you a number that's much bigger, okay? So I'm going to write down a number, 3.15 times 10 to the 7th, okay? This is a scientific notation number. Is it in good format? Yeah. Is this number between 1 and 10?
Yes.
Yes. And then times 10 to some power. Okay. Now, what does this mean? What does 10 to the 7th mean?
We need to multiply 10 times, 7 times 10. 10 times 10, the result, multiply by 10 and keep going.
Now it's going to take a long time if we do it like that, right?
Yeah.
So you can do it. Do you know the answer? What happens? What do you get when you take 10 to the 7th? Maybe you don't know.
I need to use calculator.
Okay, but I want to teach you a faster way. Okay, you don't need a calculator. Are you ready?
Yes.
You put the 1, and then you add 7 zeros.
Oh.
That's what happens when you have 10 to the 7th power.
Cool.
So what's 10 to the 6th power? What do you get?
I'm going to get 1 and 6 zeros.
Do you recognize that number? Maybe you make a lot of money in life, right?
$1
a million.
million.
This is 1 million, right? Yeah. I'm going to give you $1 million right now. No, I'm just kidding. If I have that much money, I'd give you. Okay. Now, what about this one? This is 10 to the 6th. What is 10 to the 7th? What would 10 to the 7th be?
10 millions.
Of course. Very good. So you see, this is a big number. And so instead of writing this big, long number, I can write this number, very small, right? Much more efficient.
Yeah.
Okay, so now I'm going to show you a little trick right here for taking this number and turning it into a regular number like this, okay? So we're going to take the first part of the number, 3, 1, 5, okay? But how many places did we move it to get it to be here? So you see this number, remember, was the number of places that we moved it. How many places? So we moved it, sorry, you see we up here, we moved it 1, 2, so we put 2. But if you have a 7, how many places did you move it? 7 places.
Oh, 7 places.
Okay, so watch what I do. Here's where it began, right here. Here's where it began, right? I'm gonna go 1. Uh-oh, I ran out of numbers, right? I ran out of numbers. So I'm just gonna add zeros.
Zeros.
I need to add, right? How many more? 3, 4, 5, 6, 7. I did too many. You don't need this last one.
1, 2, 3, 4, 5, 6. I think you add one more, no?
I put too
start
many.
by that one?
Yeah, so only 5 more zeros, right? So 1, 2, 3, 4, 5, 6, 7.
6,
okay?
7.
Now I'm gonna put the commas in. What number is this number?
31 millions 5.
500,000. Yes, very good. Yes, 31,500,000. Remember, what is 10 to the 7th? What was it?
10 millions.
10 million. So when you take 3 times 10 million, what do you get? You get 30 million, right? So 3.15 times 10 million is 31,500,000. So you see how we did that? Let's try it. Let's see if you can do it now. Okay. So I'm going to give you an example, a big number, really big number, and you're going to tell me what the right answer is. Okay. So here we go. 9, 4, 7, 2, 0, 0, 0. There's my number. So you're going to tell me what it is in scientific notation.
I'm lost.
So what is the scientific notation? You have to have 2 numbers. One part is between 1 and 10. Where's the decimal point? At the end of the number. If you don't see it, you put it at the end of the number. So now tell me what you do. What do you do?
I need to do 9047.
What is it?
Oh no, 947. No?
No. Where is the decimal point when you're finished?
Next by the 0.
Right here?
Yes.
I'm going to move it. Is this number between 1 and 10?
Oh, I know. Yes.
You know what you have to do, right?
Yeah. Let's see. 1, 2, 3. Number 2 is less than 10.
Yes. Give me the number.
10.
Tell me the first part. What is the first part? A number between 1 and 10. Give me the number.
Number 2.
I didn't leave.
Here?
No.
Here?
No.
Here?
Yes.
No. That's 947. Too big.
Oh, too big?
You have to be between 1 and 10. Keep going. Is this too big? 94. It's too big? Bigger than
Yes.
10?
Yes.
Keep going. 9.4 is too big?
No, it's less than 10.
Yes. So that's the
Yes.
answer. So what do we do? Okay. 9.472. And how many places did we have to move it?
1, 2, 3, 4, 5, 6.
So what do I write? Times 10 to
10,
the?
10 to the 6.
Very good. That's how you do it. Okay? So
Okay.
that's scientific notation, but Maria, it's not just big numbers. Sometimes the numbers are very small. Okay, so I
Okay.
never want to write this number, but I'm going to do it for you. Okay, are you ready?
Thank you.
Are you ready? It's a big
Yes.
number.
All right, I need 2 more bombers zombies.
Point. 0. Actually, I feel like it's too big. I think we're going to do a smaller one. It's too many numbers. Here we go. 0, 0, 3, 9. There we go. Okay.
Okay.
Is this number between 1 and 10?
The 9.
So I need to move it, right? I need to move it
Yeah.
here.
Oh, number 3.
Yeah, past the 3, right?
Yeah.
So this time it's 3.9, but you see we didn't move it the same way, did we?
Yeah.
We moved it to the right, not to the left. It's different, right?
Yeah.
This number
was
is
a little
very big. This number is very big, and this number is very small.
Oh, okay.
So I'm going to put times 10 to the, but this time I'm going to use a negative power. Okay, so 1, 2, 3, 4.
4
I'm going to
minus
put
4.
10 to the negative 4 power, like that. Does that look familiar or is it confusing?
No, it's okay, Eileen. I was a little
Recognize it?
confused at the beginning. Yeah.
Okay. So maybe I should just remind you, if you don't remember, what does this mean, negative power, right? What do I put? Let's put 10 to the negative 2. What does this mean?
But they have 2.
What does it mean?
This word.
Do you know?
That's fine. They're easy.
It means 1 over 10 to the positive 2. That's what it means.
Oh.
This is the same thing. That's what it means. Whenever you see a negative power, it means you're going to divide by the positive power. What's 10 to the second power?
What? What did you do?
Divide by the positive, you say, before the. Okay.
So you put the same number, but it's going to be this positive power this time. What's 10 to the second power?
We can't.
10 times 10.
Minus 2 equals 1 to the 10. It's going to be equal to 1 over 100.
Yes, that's correct. 1 over 100, okay? So that's what negative power means, okay? Actually, do you know this thing? This is important. What if you take 10 to the 5 multiplied by 10 to the 9, like that? Do you know what you get?
I'm going to add
Come down here, please.
5 plus 9.
Exactly. So what do you get?
It's going to be
That's my main concern.
10 to the 14.
Very good. Okay, you don't need my help. Okay, let me show you one more thing. What about 10 to the 10th divided by 10 to the 4th? What do you get?
What is this shit?
Hi, Pedro. If you have any questions, please turn on your mic and just ask them. You don't need a video. Just ask a question if you have one, or you could put it in the chat, and I'll see it there. Either way. So what do you do when you have 10 to the 10th divided by 10 to the 4th?
Yeah,
Is that confusing?
Yes.
Okay. What does 10 to the 10th mean? It means 10 times 10 times 10 times 10.
Oh.
That's a lot of 10s, right?
Yeah,
times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7 times 10 times 10 times 10. Okay. What's 10 to the 4th? That's easier.
Oh, it's going to be 10 times 10, 4 times only.
Yes. Now, do you remember in math, when you have the same number in the top and in the bottom, what can you do?
It's going to be a whole number.
You can cross it off, right? So
Uh-huh.
one of these, two of these, 3, 4.
4.
So I cross off 4 of them. How many are still left?
6.
So 10 to the 6. So how do you get 6? This is what we did, Maria. We did 10 minus 4. That's what we did.
Okay.
So you don't have to do it this way ever again. Okay, I just wanted to show you. What do? You subtract the powers.
Oh, okay.
That's it.
10 minus 4.
Yeah, sorry, 10 to the, yeah, so 10 to the 10 minus 4. Okay.
Okay.
Does it make sense?
Yes.
Okay, let's do one more. 10 to the 8 divided by 10 to the 12th. What do you get?
I'm going to do the same. I'm going to put a line, big line, and then I'm going to, on the top, I'm going to be 10 times 10.
But you don't need to do all of that,
times
Maria.
8 times.
You don't want to do all that. Just do it this way.
Okay.
Do it this way.
Okay.
So 8.
It's going to be minus 4.
Very good. Good. That's it. Good, good, good. Okay. So I just show you this because it's not, we don't do a lot of math, but we do a few things. And so these are hard if you haven't done them and you haven't done them in a while. But I think that with a little practice, you can do anything. Okay.
Okay.
I promise you, with a little practice, you can do anything. You can get a PhD if you want one. Okay. All right.
It's a long time that I was studying my high school. Maybe when my last time was when I was 18. It's long time.
Well, you have a lot. We're going to be covering so much wonderful material. You're going to like it. It's really wonderful.
Thank you.
Okay.
Yeah.
So let's teach you one more skill. Okay. You have to learn how to, not a lot, just a little tiny bit. We're going to multiply and divide. That's the first one. Okay. With scientific notation, right? With scientific notation. And we don't do a lot, but just a little bit, simple things, okay? So let's take some numbers and let me put, you know, let's say 8 times 10 to the 7th times, let's make it simple, 1 times 10 to the 5th. Okay, so what do you do in this case? It turns out that the reason we were using scientific notation, it turns out it's much easier to do the calculation.
Okay.
You don't actually do the whole thing. You do it in steps, right? You do the first part
8 plus
times the
1,
first part.
9.
Yeah. No, 8 times 1. 8
8.
times 1.
Oh, perdón. 8. Sorry.
8. Okay. 8.
8
That's
times
8 times 1, right? And then we do this part.
1. Then it's
10 to the 7th times 10 to the 5th.
12.
Yes, perfect. Good. That was easy,
Oh no,
right?
sorry.
No, it's correct.
7 times 5.
No, 7 plus 5, right?
Oh, 7 plus
you-
5, 12.
When you multiply powers of 10,
Uh-huh.
right? You add the powers together.
Oh,
Okay.
okay.
So you did that right. Good job. Great. Let's try a little harder one.
Okay.
You're going to graduate. You're going to get a little bit harder. No, just a little bit harder.
Uh-huh.
Here we go. 2, I'm going to give you a little bit harder. 2 times 10 to the 3rd times, let's see, 7 times 10 to the 4th. Okay?
Okay.
So this means multiplied, right? I don't have to put a multiplication symbol. There's 2 numbers next to each other.
So it's going to be 2 times 7 is going to be 14.
14, okay?
Times 10 over 7.
10 to the 7th. Good. Now, the only problem, just a small detail, is this number between 1 and 10.
Mhm.
Is this number between 1 and 10?
This is bigger than 10.
No.
So then something's wrong. It doesn't fit, right?
Uh-huh.
It has to be between 1 and 10. So let's look at the number 14 for a moment, okay?
Mhm.
Where's the decimal point?
1.4.
Yes, very good, good. So you move it one place. What is it?
Uh-huh.
1.4 times
10
To
to
the?
the 7.
No, how many times did we move it?
Oh, sorry. 1.
10 to the 1,
One.
okay? Now this is going to go in here, right?
Mhm.
So look at what we get. We got 1.4 times 10 to the 1st times 10 to the 7th. What do you do?
1.4 times 1.4 times I think 100.
What's the 1 and the 7 do? What happens? Ten to the first,
we need to add.
you add the powers together, right? So
Yeah.
what do you get?
100. Oh, sorry.
10 to the 8.
10 to the 8. Sorry.
Okay, so this one, is this good scientific notation?
Yes.
Is this number between 1 and 10?
Dude, it's so because they have that.
1 is less than 10.
No, I know, but it has to be bigger than 1 and less than 10. Is this one bigger than 1?
1?
Is 1.4 bigger than 1?
Yes.
Yes, it's $1.40, right?
Uh-huh.
Instead of only $1.
Mm-hmm.
Okay, so this is good notation. This is good. Okay, this one wasn't quite right. Just a little bit wrong. Do you see how we changed it?
Yes.
So they're the same number, but this one is in the good format. This one's not quite as good. They're the same number though.
Mhm.
Okay, all right. So you can use this trick sometimes. I'm gonna show you a little trick here. Let's see, 4 times 10 to the 5th.
God, that wasn't me, but. No.
Where's the decimal point? Well, it's right here.
Yeah.
Okay, that's good scientific notation. What would happen, I want to ask you a question. What would happen if I wanted to put 40 times 10 to some power? What should the power be to be the same number? How do I do
10,
that?
to the, if we move it's going to be 1.
10 to the
If we
what?
move to the left, starting from the 0
Yeah.
on the bottom, it's going
Is
to
it
be
positive
1.
or negative 1?
Why is going to be negative?
Yeah, because we're going to this direction. So this number is right here, and then times 10 to the 5th. So you get 40. And what's negative 1 and positive 5? Negative 1 and positive 5
Negative
make
4.
positive 4. Very good.
Positive.
Okay, so these are the same number. This one is not good scientific notation, but you need to be able to do something like this as well. Okay, now I'm going to show you one final trick, and then we're ready. We're going to show you how to do adding and subtracting. Okay, you ready? Okay, let's go back. Let's go. Let's learn how to add and subtract, okay?
Okay.
It should be easy. Don't worry. And by the way, we don't do a lot of this. It's just, I just want to teach you the skills, then you're done. You got it for the course, okay?
I'm going to practice. Tomorrow I'm going to be ready.
Yeah, I'm going to give you a little quiz to practice later today too, so you can try it yourself. See if you find out. After we practice to get together, you should, when I give you the quiz, you can see if you're getting it or not, okay?
Okay.
But before you take the first exam, you want to make sure you can do it, okay?
Okay.
So let's try it. Let's do one more little trick though, okay?
Oh, I got 3 down here. Hold on.
Now, what if I wanted it to become 0.4, right? Then how do I make this 0.4, right? This time I moved it one place to the left, right? So instead of 10 to the minus 1, what would it be? 10 to the positive 1, right?
Oh, wait.
So then we have times 10 to the 5th.
Okay, I finished mine. Mine's done.
So it's 0.4. And this time we're going to add the 1 and the 5 together. What do we get?
10 to the 6.
Yes, right? So all of these are the same number. All of them are the same number. Okay? All right. So why did I teach you this? Because you're going to add some numbers together, okay? So we're going to start off with a number. Let's take, and let's make it 5. 5 times 10 to the 6th power plus 4 times 10 to the 5th power. Okay, so this is a number.
Just go. Just go.
Okay, so
I didn't know.
there's actually a trick you can do. I don't know if you want to just do this. Actually, I feel like maybe we should do this just to understand. What is this number? What if I took this out of scientific notation? What would it be? 10 to the 6th. What does this mean? You remember 10 to the 6th, Maria?
I forgot.
Okay, it's 5 million.
Oh, 6 times 0.
Yeah, with 6 zeros, right?
Yeah.
So you see, when you have this number, you just move the decimal place 6 times. And there's no number, so I just put zeros there.
Right.
Is that okay?
Yeah.
What about this number?
It's going to be the same. It's going to be 4 plus 5 zeros.
What number is this?
400,000.
Yes, very good. And so what do you get if you put 5 million?
5 million.
What do you get when you add them together? What do you get?
It's going to be 500 million. Oh no, wait. 3. Wait. It's going to be 500 million 400,000.
So it's going to be 5 million.
5 million 400,000.
1,000. Okay, that's the answer. It's pretty simple, right?
Uh-huh.
Okay, now the problem is when you look at the scientific notation, if the powers don't match, we can't just add these numbers together. They don't go together. They're different places, right? This 4 and this 5 are not in the same place. So what we have to do is we have to change the number, one of these numbers, so that the powers match, right? So make the powers match. Okay? So let's try to make it become a 6, right? How do you make 4 times 10 to the 5th become something times 10 to the 6th, right? So here was the original number. How did we get 10 to the 6th?
We are going to,
Which one of these is 10 to the 6th? The top or the bottom?
the bottom.
The bottom, right? So what did we do? We changed it to 0.4 times 10 to the 6th. Now, because the powers are the same, you can just add these two pieces together. What's 5 plus 0.4?
Is
Or just go.
5 plus
9.4.
5 plus, yes, 5.4. And then the power is the same for both of them. You bring it and put it together with the next one, okay? So now look down at our number here. Where's the decimal point?
On the first zero.
Yeah, at the end, right?
At the end.
And so how many times do you need to move it? How many places?
1, 2, 3, 4, 5, 6.
That's right. So what's the number in scientific notation? 5.4 times 10 to the 6th, right? The same answer. So the trick is that you have to make the powers match. Okay, let's try it again. Only this
Wait,
time.
can I? Thank you, please. Thank you.
Sure. You finished?
Yes.
Oh, okay. All righty. Okay, thank you for coming. Okay.
Thank you.
You're welcome. Bye.
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 Do I need to leave?